Hello everyone. Today we shall see measures of dispersion. We have seen measures of central tendency as a unique value or a single value representing the entire data set. But that value fails to give us the complete idea about the data. The extent of variation of data cannot be measured with the help of a measure of central tendency. To understand this concept in detail, let us have a look at the following example. Consider three sets of data. The first set of data is 50 each, hence the mean of this set is 50. The next set of data is 48, 50 and 52. The mean of this data set is also 50. And the third set is 150, 99. The mean of this data set is 50 as well. Now, the mean fails to identify that in all the three sets, the variation of the data observations from the mean is different. In the first example, first set, there is no variation at all. That is, each observation is same as that of the mean. Hence, the value of variation logically is 0. There is no variation. In the second set, the values are away from the mean, but the distance of observations from mean is not much. Whereas in the third case, there is a vast difference in the values, or there is a big variation in the values from the mean. Hence, measure of central tendency will just try to give us a single value to represent the data set, but it will fail to give the extent of spread or scatter of or dispersion of the data. Hence, we need to study measures of dispersion or measures of variation in order to see how spread, varied or scattered is the data away from this central value or this mean. The best method of measuring the variation of observations is variance, and it is defined as the average of squares of deviations of all observations from the mean. I repeat, average of square of deviation of each observation from the mean. Hence, smaller the value of variance, higher is the degree of uniformity, because variance represents the extent of spread. So, smaller the value of variance implies smaller is the spread. To calculate variance, for raw data, variance is given as, let us try to interpret the definition along with the formula. So, average, that is summation upon n of squares of deviation, square of xi minus x bar, each observation from the mean. And when the data is grouped or ungrouped, we will have to convert the frequencies or multiply the frequencies with the data or the square of deviations, so that the average can be obtained by dividing by summation of fi. Now, let us look at standard deviation. Variance will have units in terms of squares of the unit that the data has. And in order to use a measure of variation which has units at par with the data, we use standard deviation, which is the square root of the variance, so that the units of standard deviation will be the same as that of my data units, or units of xi, units of x bar, units of median, mode, whatever. So the standard deviation will be defined as square root of average of squares of deviations of all observations from the mean. So standard deviation is square root of variance. If we have two or more data sets, we cannot compare it directly with variance because the two data sets may be measured on different types of units. Hence, with the help of our measure of variation, that is standard deviation, we will calculate coefficient of variation, which being a coefficient will have no units and hence will be able to compare different types of data, variation among different types of data with the help of it. So the coefficient of variation is defined as standard deviation divided by mean into 100. And since standard deviation and mean will have same units, coefficient of variation will have no units. Let us now have a look at examples of calculation of standard deviation. Now we have to calculate mean and standard deviation for the given raw data. Now the mean, because we require the mean for calculation of standard deviation. So mean for raw data is summation xi upon n. So add all the observations and divide by total number of observations. We have 10 observations. So just add the 10 values and divide by 10 to get the value of mean. Now the formula of standard deviation says that you take the square root of average of the squares of the deviation of all observations from the mean. So the calculation here on the screen will justify the formula. It is taking the square root, it is adding the values and dividing by the total number of observations, the squares of deviations of every observation from the mean 11, and the value is 4.732864. Now instead of raw data, if we have ungrouped data, for ungrouped data mean is calculated as summation fi xi upon summation fi, for which this is the method that we use. Now here the question asks for variance and not the standard deviation. So there will be no square root sign. So we just have the average of the squares of the deviations of observations from mean. So the formula and hence the value of variance. Now instead of ungrouped data, if we have a group data, in group data you will find that the values of class intervals and the corresponding frequencies will be given, for which instead of the direct values of xi, for example, which is the number of patients in this case, we shall use the class mark of each class interval and the entire procedure will be same. So for this example of computation of mean and variance, for the given data, we have calculated the class marks x as 6, 10, 14, 18, 22, 26, 30, 34 and 38. A class mark is the average of the boundaries of the class interval for each class interval. And we have used the class marks instead of values of xi and done the same procedure of calculation of mean as well as variance, and this is what we get. Thank you.